Hey guys, if you've ever felt a breeze so cold it almost whispered through your bones, or watched frost draw delicate lace on a window pane while the world hushed itself to sleep, then tonight's quiet tale might feel like home, or something even quieter. Welcome back to Boring Science for Sleep, where science isn't rushed or shouted, but breathed softly in the dark corners of your thoughts. Tonight, you're not just here to learn, you're here to drift, to explore, to wander the loneliest, coldest places the universe has ever known. But before we begin this curious journey into frozen atoms and sleeping stars, let me ask, where are you watching from tonight? Let us know in the comments. And if your eyelids grow heavy before we finish our little voyage, tap that like button and subscribe so you can find your way back whenever sleep needs a guide. Now close your eyes and imagine the warmest memory you have. Maybe the hug of a wool sweater after coming in from the snow, or steam rising from a cup you held with both hands. Let that warmth flicker once more in your mind before we gently take it away. Because to understand cold, truly understand it, you must first remember what warmth feels like. Cold is not just the absence of heat, but the absence of motion, of dance, of life. It is stillness in its purest form. And so you find yourself sinking into that stillness now as we begin with the coldest temperature that can ever exist. Absolute zero, negative 273.15 degrees Celsius, the temperature at which atoms themselves stop wiggling. Imagine that. Everything you've ever known is made up of particles in motion, jiggling, spinning, nudging one another like restless children in the dark. But at absolute zero, all that stops. The dance ends, the universe holds its breath. It's a number we've never quite touched, not really, not completely. Even in the coldest labs here on Earth, we only come hauntingly close, mere billionths of a degree above that ghostly still point. And yet just trying to reach it tells us something beautifully human. We chase the unreachable, not because we must, but because we're curious, because we wonder, because we dream in decimals. Think of the coldest you've ever felt, your skin prickling, teeth clattering, the kind of chill that makes the inside of your nose freeze slightly with each breath. That is a mere nuisance compared to the cosmic cold. In deep space, far from any star, temperatures drop to around 2.7 Kelvin. That's just above absolute zero. It's not a cold that stings, but one that waits. A cold that has never known the heat of a campfire or the warmth of a heartbeat. And still colder than that, hidden in the constellation Boötes, drifts the Boomerang Nebula, the coldest known place in the universe. Colder than space itself, just 1 degree above absolute zero. A dying star has cast off its outer layers in a final breath, and those gases expand so quickly that they cool beyond what the vacuum of space normally allows. It's not just empty, it's the absence of motion, of noise, of time. If you were to drift there, wrapped in silence, even the atoms in your eyelashes would stop whispering. But before you get too lost, let's come back to the body for a moment. Your body. Even now, as you lie still, warmth flows through you like tiny rivers. Your core temperature is a gentle furnace, about 37 degrees Celsius. And your body works hard to keep it that way, because even a few degrees drop begins to change everything. At 35 degrees, you're hypothermic. Your speech slurs, your limbs feel drunk. At 28 degrees, your heart may forget its rhythm. At 25, your consciousness begins to unravel. Cold doesn't attack. It erases, slowly, lovingly, like snow covering tracks in the woods. And all the while your brain, the crown jewel of your body's heat, tries to protect its fire. It reduces blood flow to your fingers, to your toes, keeping everything else alive a little. longer, but in the coldest places of the universe there is no fire left to guard. Let's rewind time now. Imagine ancient scientists with trembling fingers and soot-stained notebooks trying to make ice colder than ice, to find the bottom of temperature like a child trying to dig through the earth with a spoon. Their tools were primitive: salt and ice, thermometers filled with coloured alcohol, brass knobs and mercury columns. And yet they were chasing the edge of motion itself. Over centuries, those tools evolved, becoming vacuum chambers, magnetic traps and laser cooling systems. In 1995, scientists at the University of Colorado created a Bose-Einstein condensate, cooling rubidium atoms so close to absolute zero that they merged into a single quantum state, behaving as one dreamy entity. The atoms stopped acting like individuals and began whispering in unison. In a way, they fell asleep together. And now you are drifting alongside them, perhaps. Let's stretch our minds even further, into time, into relativity, into the frozen stillness of black holes and the vast silence between galaxies. In these places, heat does not travel. There are no molecules to vibrate, no friction, no sound. You cannot warm your hands in a void. And yet, even there, the quantum world still breathes. Tiny virtual particles flicker in and out of existence near event horizons, like shy fireflies. And they have temperature. They radiate just a little, in the softest whisper Hawking could measure. The coldest parts of the cosmos are not dead, they are dreaming. The second law of thermodynamics tells us that entropy, the tendency toward disorder, always increases. But cold is order, frozen time, a crystal lattice that doesn't care if you're watching. So when you lie here, wrapped in silence, know that you are not escaping warmth. You are entering something more ancient, something simpler. A still illness older than stars, and perhaps the coldest question of all isn't how low can temperature go, but why does warmth matter at all? What makes motion meaningful? What makes the jostling of particles in your chest into something you call feeling? The answer is as soft as breath. Because in the coldest places of the universe, where motion fails and silence wins, you begin to feel your own heat more deeply. Not just your body's warmth, but your presence. The simple, quiet miracle of still being here. And so you drift on, gently, past sleeping atoms and snow-covered galaxies into the next layer of this frozen dream. And as you continue to drift through this vast frozen hush, the warmth of your body feels smaller now, like a candle in an abandoned cathedral, flickering softly against the weight of silence that surrounds you. You're not lost, but suspended, as though the laws of time have taken a gentle pause just for you. In this quiet, the very idea of heat begins to change. Not just as something you feel, but as something the universe is always losing. You see, heat isn't a thing, it's movement. It's energy transferred, the chaos of motion jumping from one particle to another like a game of tag in the dark. And cold, well, cold is just the absence of that game. No one's chasing, no one's moving. The game is over. The second law of thermodynamics, the gentle tyrant of the cosmos, says that all systems tend toward equilibrium. That's just a fancy way of saying everything eventually cools down. Your coffee, your campfire, your heartbeat, even the stars. And here's the strange, sad poetry of it. The universe is slowly freezing. Not suddenly, not violently, but like breath fading on a mirror. It's called heat death. A moment in the unimaginably distant future when all energy is evenly spread, when no heat flows and nothing happens ever again. The universe won't explode. It'll sigh itself into stillness, and you're part of that story. Your warmth, a brief rebellion against the cold that waits patiently at the end of everything. But that patience, It's cosmic. We're talking trillions of years, longer than the Earth has existed, longer than even stars can remember. Still, it's happening. Entropy is increasing, and in that knowledge, you find an odd sort of comfort, like knowing that even the wildest bonfires must eventually become ash. So let's return to your body for a moment, because it's an expert in managing this fragile flame. Your hypothalamus, a small almond-shaped region deep in your brain, is your internal thermostat. It balances your temperature within a narrow, sacred range. It tells your blood vessels when to tighten, your muscles when to shiver, your skin when to sweat. It's a quiet, tireless conductor keeping the orchestra of your cells in harmony. Even as you sleep, it works, even now as you listen. But cold is clever. It sneaks through cracks, through damp socks, through icy winds that cut across the neck like forgotten secrets. And when it takes hold, your body starts to prioritize. The vital organs are first in line. Blood leaves your fingertips and toes, pooling in your chest, your head. You feel the sting of absence before anything else. Not because cold wants to hurt you, but because your body loves you. It gives up parts of itself to protect the whole. And in that trade-off, there's something beautiful, something ancient. Animals do it too. The Arctic ground squirrel, for example, has a core temperature that drops below freezing during hibernation. And yet, it survives. Its heartbeat slows. Its brain quiets. It almost becomes a rock, a soft, breathing stone beneath the snow. And when spring returns, so does it. Not dead, just paused. Think of that, a pause so deep that life barely whispers and yet returns like nothing happened. Nature doesn't fear cold, it understands it, embraces it, adapts to it. In the high altitudes of the Andes, people live with thinner air and colder nights, their blood richer in oxygen, their bodies conserving heat like living furnaces. Penguins huddle in circles, passing warmth between them like secrets, always shifting, never alone. Even plants, those silent chemists, have antifreeze proteins that keep their cells from bursting in the frost. The world doesn't avoid cold, it evolves alongside it. And maybe, in your own way, so do you. Have you ever stood outside on a winter night, alone beneath the stars, and felt the way the cold strips everything unnecessary away? It doesn't just freeze, it clarifies. You hear your breath, you feel your heartbeat, you remember yourself. In cities where sound never stops, cold is one of the few things that can bring stillness. It hushes the streets, silences the insects, draws curtains on noise, and in that hush, there's room to think, or not think, just be. That's part of why people seek cold, why we climb snowy peaks, walk through falling snow, or press our faces against windows frosted in lace. There's a yearning there, a yearning for something simpler, something slower. But even in our pursuit of cold, we can only go so far. In laboratories, scientists have developed techniques like laser cooling, where atoms are bombarded with photons to reduce their motion. It's counterintuitive, using light to create cold, but it works. The atoms slow down, their vibrations quiet, and they begin to behave in strange ways. At near absolute zero, matter can act like waves instead of particles. This isn't science fiction, it's quantum physics. The world becomes dreamy, blurry, overlapping. Particles exist in multiple states. Location becomes uncertain. The colder it gets, the weirder it gets. It's almost as if cold reveals the universe's secrets, not with a shout, but a whisper. And those secrets are not loud or sharp or explosive. They're subtle, like ripples in a pond beneath the ice. The cosmic background radiation, the afterglow of the big. Bang is just a few degrees above absolute zero. It's the universe's baby picture, cooled and stretched by time. We're swimming in it constantly, this ghost of creation. The cold has always been here, before you were born, before the earth formed. And when the last star flickers out, the cold will remain. Not as an enemy, but as a backdrop. The canvas behind every fire, every hug, every sunrise. And so, as you lie here, warm beneath your blanket or tucked into a quiet room, you are a small ember glowing against an ancient chill. A flicker in the vastness, but you're not alone. Every person who ever lived carried this warmth too, passed it on, through touch, through breath, through stories. You carry theirs and someone will carry yours. The cold may one day win, but not tonight. Tonight, the flame is still burning, softly. And as we drift deeper into this frozen journey, the next stop is even stranger, where time itself begins to slow in the presence of extreme cold, and the ticking of the universe stutters like a clock winding down in snow. And now, as your body sinks further into the weightless calm of this chilly voyage, a strange realization begins to settle over you like a snow-laden cloud. The colder it gets, the slower things seem to move, not just in space, but in time itself. You've probably felt it before, in the most subtle of ways. How winter evenings seem to stretch longer than summer nights. How cold air makes everything feel a little more suspended, like the universe is exhaling in slow motion. That's not just poetic imagination, it's a clue to something deeper. In the realm of physics, time and temperature are oddly intertwined, like two dancers moving in opposite directions on the same floor. Heat, after all, is a form of movement, atoms jostling, bouncing, whispering against each other in ceaseless chatter. But as cold settles in, that chatter quiets. The s'enfile. Atoms stop bouncing, the motion stills, and when motion stills, so does time's rhythm. Not entirely, but noticeably, like a metronome ticking slower. In ultra-cold conditions, such as those found in the most precise atomic clocks on Earth, scientists have observed that timekeeping itself changes. These clocks, using atoms cooled to nearly absolute zero, can measure time so accurately that they won't lose a second for billions of years. And yet, even they reveal that time does not tick the same in all places or under all conditions. Gravity affects it, speed affects it, and yes, temperature does too. Time in this sense is not a constant drumbeat, it's a fabric, rippling, stretching, folding in on itself under the quiet weight of cold. Imagine, then, drifting in one of these frozen pockets of the cosmos, a place where heat has long vanished, where atoms barely twitch, where the stars have grown dim. Here, time would feel different, not wrong, not broken, but sleepy, like it's curled up in a blanket, waiting for something to stir. And if you were to linger there, float in that motionless hush, you might feel as though you'd stepped outside the regular rhythm of your own life, not aged, not lost, just paused. Like a snowflake resting on a branch, weightless and perfect and fleeting. Even Einstein, with all his equations and chalkboard diagrams, once said that time is relative. And in the coldest corners of reality, that relativity becomes something you can almost feel brushing against your skin like frost. This isn't science fiction. It's a truth buried inside the particles of your own body. Your cells, your neurons, your breath. They all dance to time's rhythm, which is governed in part by temperature. When your body cools, your processes slow. Metabolism eases, thought lingers, reaction stalls. That's why hypothermia doesn't just numb the fingers, it numbs the mind. Time becomes syrupy, memories feel slower, movement delays. And yet there's something tender in this. Slowing down. Your body isn't failing. It's protecting. It's conserving. It's wrapping time in cotton, shielding you from chaos. The world, in that moment, becomes quieter, softer, more forgiving. You might even imagine that if you could lower your body temperature just enough, without harm, without fear, you could slip beneath time's fingers and wait there for as long as you liked, like seeds buried in frozen soil, waiting for spring. Scientists have long dreamed of this too. Cryonics, the idea of preserving human life in deep cold, hoping that one day, in a warmer future, medicine might catch up and bring someone back. It's not science we've mastered yet, but the ambition says something about us, doesn't it? That even in the face of death, we believe cold can be a bridge, a pause button on a life worth saving. A way to trade time for possibility, and in some ways, it's not so far from what already happens. Certain frogs, like the wood frog of North America, can literally freeze during winter. Ice forms in their bodies, their hearts stop beating, their blood stops flowing, and yet, come spring, they thaw, they wake. They hop away like nothing happened. Their bodies have learned how to suspend time, to become part of the cold without being lost in it. And that's not a miracle. It's biology. Cold slows the degradation of cells. It halts chemical reactions. It buys time. That's why we use freezers, why we refrigerate organs before transplants, why glaciers preserve the past so well, trapping pollen, air, even ancient viruses in their icy grasp. Cold, in all its silence, is a time capsule, a way of holding on. Even light, the fastest thing we know, becomes trapped in the coldest substances. In certain materials cooled near absolute zero, light slows down dramatically. It's as if the very speed limit of the universe begins to waver. In one experiment, scientists slowed light to just 17 meters per second, about the pace of a jog. Imagine that. Light, slowed to a jog, meandering like a sleepy traveller through a cold hallway of atoms. And it's there, in those moments, that you begin to grasp just how elastic reality really is. The laws you thought were unbendable, like time, motion, light, start to sway, gently, quietly, like reeds in a winter pond, and you, lying still now, are part of that sway. Your breath, your heartbeat, your mind, all syncing with the cold's rhythm, which is no rhythm at all. Just space, just waiting. And as your thoughts drift further, you might wonder, what would it be like to live in a world where time had always been slow, where suns rose not in minutes but in millennia, where seasons took centuries to change? Would you notice? Or would your perception adapt, your sense of motion shift to match the scale? Maybe time is not a ticking thing at all, but a feeling. And cold, in all its power, simply helps you feel it differently. And so, as you rest deeper into this journey, your body calm, your thoughts unfurling like fog in a frost-bitten field, we drift next toward the instruments we've used to measure such things. Thermometers, timepieces, and tools built not to control cold, but to understand it. And in that understanding, perhaps we've built a bridge between warm hands and the indifferent frost of the stars. The cold doesn't speak in words, but it leaves traces, subtle, shifting fingerprints that humanity has spent centuries learning how to read. And as your mind drifts deeper into this slow and silent voyage, the warmth of invention begins to flicker through the stillness. Imagine holding a glass tube filled with mercury, the silver liquid trembling slightly as it rises or falls, not because the mercury wants to move, but because it must, because heat, or the lack of it, demands it. That's a thermometer, simple in appearance, once profound in meaning. A whispering messenger between your world and the vast invisible spectrum of temperature. And like all things born of curiosity, it began with a question: how do we see what cannot be seen? For temperature, that answer was motion made measurable. As far back as the early 1600s, Galileo Galilei, yes, the same one who watched planets dance and dared to say the Earth was not the centre, began experimenting with thermoscopes. No scales, no numbers, just the rising and falling of liquid, like the breath of a sleeping child. It wasn't precise, but it was poetic. Over time, scientists gave temperature a language. Celsius, Fahrenheit, Kelvin, each one a dialect of warmth and cold, each one a way of carving the invisible into something chartable. And you too have used them. Perhaps to check for a fever, to test bath water, to see whether a winter night dipped below freezing. Each time, you're not just observing a number, you're connecting with a force older than language, a fundamental property of the universe itself. Cold, after all, is not merely a sensation, it's a measurement of motion. Less energy, less vibration, less life. And to measure that, we had to build machines delicate enough to feel what we could not. Thermocouples, resistance thermometers, infrared cameras that paint heat as glowing red and cold as ghostly blue. The colder we tried to measure, the more precise we had to become. Because at the edge of absolute zero, small changes matter. Atoms move so little that even a whisper of warmth is noticeable, and measuring that meant building instruments that could detect not just temperature, but time itself. Because to measure temperature, especially in the extreme cold, you must also measure how things change, how fast atoms jitter, how quickly they react. And that brings us to clocks, to timekeepers, the unsung heroes of scientific cold. Clocks are just thermometers of a different kind. They don't measure temperature, but they do measure consistency. The tick, the tock, the rhythm of the universe kept in sync by something unwavering. In the beginning, humans watched the sun, the moon, the stars. Cold didn't matter then. It was all about the sky. But as we looked inward into atoms, we discovered that certain atoms vibrate at such perfect intervals that they could mark time better than any pendulum or shadow. Atomic clocks were born, devices so precise they lose only a second every few billion years. And how do they stay that precise? By keeping their atoms cold, cold enough that motion doesn't distort the rhythm, cold enough that noise is minimized, cold enough that time becomes almost pure. You are lying there now, surrounded by invisible clocks. Your own body is one, a collection of internal timers managing your sleep, your hunger, your warmth. Circadian rhythms respond to light, yes, but also to temperature. A small drop in your core temperature, by just 1 or 2 degrees, is part of what signals your body that it's time to sleep. That's why cool rooms feel restful, why night air brings yawns, why warm blankets in a cold room feel like lullabies. Your body doesn't just obey time, it feels it, it reads it in degrees. And just as we measure cold with tools, we also measure time's passage in memory. Think about how long winter feels when you're waiting for spring, or how brief a cold morning is when you're wrapped in someone's arms. Emotion skews the clock. Experience bends it, but cold is objective, or at least it tries to be, and yet every thermometer is imperfect. Every clock is a compromise. That's part of the beauty of science, not in its perfection, but in its persistence. We know we can never reach absolute zero, and yet we try. We know we cannot measure time without some loss, and yet we build better clocks. Each instrument is a lighthouse casti, laying its beam into the fog of the unknown, hoping to catch a glimpse of something steady. And that's where invention lives, not in certainty, but in the yearning to be certain. As you drift through this layer of thought, surrounded by invisible machines and ancient ideas, you start to realize something. All our tools for measuring cold and time are really just tools for measuring change. A thermometer watches as motion slows. A clock listens as rhythm softens. And you feel both. The slowing, the softening. You are both observer and observed. And as the cold grows quieter around you, so too does your mind. Fewer thoughts, slower breath, time gently stretching. The instruments continue their silent work, even as you surrender to sleep, because the universe doesn't stop when you close your eyes. It just hums a little softer. And next, we turn our gaze to the earth itself, and how it stores cold in deep places, how glaciers, ice cores and permafrost hold memories of ancient winters, and how the planet has its own way of remembering the cold. Beneath your feet, hidden in silence and centuries, lies the oldest kind of memory, one that doesn't speak in words or symbols, but in layers of ice stacked like pages in a book no one has fully read. And as you rest here, quiet and still, the earth itself becomes your storyteller, whispering through frost and sediment, through crystals formed under pressure so slow it feels more like waiting than forming. You see, the planet remembers the cold in ways we cannot, where your mind forgets a winter after a few seasons. The Earth remembers it for millennia. In Greenland and Antarctica, glaciers stretch across the land like ancient scrolls, each snowfall compressing the one beneath it, year after year, until time itself becomes frozen in place. Scientists call them ice cores, cylindrical records drilled deep into glaciers, revealing bubbles of air from long ago, trapped like forgotten breaths. And when those cores are lifted from their icy tombs and seeds, artfully analysed, we can read them like a story told in temperature. The deeper the core, the further back we go. 1,000 years, 10,000, 800,000. In those bubbles, we find the atmosphere of Earth as it once was. Carbon levels, methane, dust, even pollen from long-dead flowers. A single flake of ice buried under centuries of weight becomes a witness to ancient storms, volcanic winters, and sun cycles that warmed or chilled the Earth without any help from us. It's humbling, really, to know that cold is not just something that happens, but something that stays. Something that keeps a record. And just as the planet records cold, it also reacts to it in slow, monumental ways. Glaciers advance and retreat like the breath of sleeping giants, carving valleys, shaping coastlines and moving stones the size of buildings. When you see a mountain lake cradled in a bowl of stone, you're seeing where a glacier once curled itself into the land. Cold doesn't just touch the world, it sculpts it, and those changes, though massive, are often invisible in the moment. Only when viewed from far above or far away in time do we see the full shape of cold's influence. You might never notice the slow creep of permafrost thawing beneath Arctic soil, or the carving of an iceberg into an indifferent sea, but the earth feels it, records it, adjusts to it, and even in the places where cold seems constant, places where no summer ever truly arrives, life adapts. Bacteria frozen for tens of thousands of years beneath Siberian permafrost have been revived in labs. Not fiction, not myth, science. Life that slept through the rise and fall of civilizations and simply continued when the ice let go. There's something almost comforting in that idea, that even in the coldest places, even when time seems to stop, life waits patiently. And perhaps, in some way, so do you. Think of the deepest cave you've never seen buried beneath the Antarctic surface, Lake Vostok. A body of water sealed under miles of ice, untouched by wind or sky for millions of years. It's not warm down there, it's not lit, but it exists, and it may harbour life. Microbial, simple, ancient, creatures that have never known the warmth of the sun, but exist nonetheless. Cold, it seems, is not always the end. Sometimes it's just a pause, a quiet room where things are held in stillness until the right moment arrives. Your own body, in a much smaller way, follows this same rhythm. Cold can preserve you, not just in the dramatic freeze of science fiction, but in little ways. You've put food in a freezer, extended its life by stopping time. You've iced a wound to slow inflammation. You've held a cold cloth to your forehead and felt it reset something unspoken. Even the sensation of a cold breeze on a sleepless night can hush the anxious rhythm of your thoughts. That's not magic, it's biology. Your nervous system responds to temperature shifts, especially cooling ones, by altering the flow of hormones. Cortisol lowers, heart rate steadies, a chilled body can soothe a racing mind. That's why you feel drowsier in the cold, why a cool room invites longer dreams. Your body, like the earth, understands the language of temperature, even if you've forgotten how to listen. And listening is what scientists do when they study ice. They listen with instruments, with lasers, with mathematical models. They look at ice cores and see past climates, trying to understand how cold once ruled the earth. There were ice ages that lasted for tens of thousands of years, when glaciers stretched from pole to equator and the world huddled under a white sky. There were warm periods too, but the cold always came back, always returned like a tide. That's the strange comfort of cycles. They tell you that nothing lasts, but also that nothing is truly lost. What is frozen may thaw, what is still may move, and what is forgotten may be found deep in the quiet layers of the earth's ski. And so, as you drift here tonight, warmed by your blanket, slowed by your breath, you are connected to something vast and slow and old. You're not just lying in your bed, you're lying atop layers of frozen time. The ground beneath cities, forests, oceans, it all holds pieces of the past, in ice, in stone, in silence. And perhaps, if you listen long enough, you'll hear it. Not a sound, but a rhythm. Not a voice, but a feeling. The earth breathing in glaciers. The cold remembering for us what we're too brief to hold. And next we'll rise from the earth and turn our gaze outward again, to the instruments we've launched into space, seeking the temperature of stars, of gas clouds, of black voids, trying to map the cold beyond memory and matter. Out beyond the reach of human skin, beyond the rustle of trees and the sigh of ocean winds, the cold becomes something altogether different. Not just a feeling or a record, but a presence. A vast, unblinking quiet that wraps every planet, every comet, every wandering satellite in its endless arms. And as you drift deeper now into this expanding silence, imagine yourself riding gently alongside one of those satellites, floating in the vacuum where there is no up, no down, just motion and inertia, silence and signal. Up here, in space, temperature doesn't behave the way you're used to. On Earth, cold and warmth come from air, from water, from the breath of wind or the press of skin. But space has no air, no molecules to pass along heat. It's not cold in the way your fingers feel cold. It's cold in the way a shadow feels eternal. The vacuum of space doesn't draw heat from you. It simply refuses to give any back. The sun's light may blaze on one side of a spacecraft, sending temperatures soaring past 120 degrees, while the shaded side plunges to 150 degrees or lower. There is no balance, only extremes, and so to measure the coldness of space, to truly map it, we've sent out silent, tireless observers, satellites built not to speak but to sense. These instruments orbit Earth, linger in deep space, or trail behind planets, recording, temperatures we can barely imagine. Take COBE, the Cosmic Background Explorer, launched in 1989 to study the faint microwave afterglow of the Big Bang. Or WMAP, its successor, which gave us a detailed map of the early universe's temperature, a subtle speckling of slightly warmer and slightly cooler regions in an otherwise unimaginably cold void. And then Planck, the European Space Agency's telescope, which mapped the cosmic microwave background with exquisite precision, revealing not chaos, but quiet variation. These satellites didn't find explosions or storms. They found stillness. They found cold, uniform, ancient cold. The temperature of the universe itself, around 2.7 Kelvin, or 270, 45 degrees E. Just a whisper above absolute zero. This is the leftover warmth of creation. The dim, fading echo of a universe that was once too hot to exist in any form we understand. And now, billions of years later, that fire has cooled to a murmur, a thermal hush spread evenly across the sky, and you, lying still, are bathed in it. You can't feel it, but it's there. Every second of every day, the entire Earth is being gently wrapped in the soft radiation of a past too far to see, too cold to notice. And when you gaze up into the night sky, you're not just looking at stars, you're looking into temperature, into degrees and decimals scattered like frost across a dark canvas. The satellites we build aren't cold themselves, not at first. In fact, many of them must be cooled artificially just to function. They're sensors designed to detect faint heat signatures from galaxies and gas clouds are incredibly sensitive. So sensitive, in fact, that even the warmth of the spacecraft itself could distort the data. So we cool them with liquid helium, with radiation shields, with systems designed to mimic the coldness they're trying to measure. It's like whispering into silence. You must become quiet yourself, or your voice will drown out what you seek. This strange dance of building heat-sensitive instruments, cooling them, and sending them into a place where warmth is a memory, feels almost like science becoming poetry. The tools must learn the language of the space they enter, and as they orbit or drift, they teach us what cold truly means. They've revealed planets with frigid atmospheres, like Neptune and Uranus, where winds howl through gases colder than anything on Earth. They've studied icy moons like Europa and Enceladus, whose crusts of frozen water may hide oceans beneath, warmed slightly by tidal forces and perhaps even life. They've shown us comets, dirty snowballs slingshotting around the sun, their cores chilled for eons in the outer reaches of the solar system. And further still, they've found dark nebulae, vast clouds of dust and gas so cold, so dense that starlight cannot pierce them. These are stellar nurseries, paradoxically frozen and full of potential, where new stars will someday ignite from the cold, compressed whispers of matter. Even the Voyager probes, launched in the late 1970s and now billions of kilometres from Earth, have tasted the edge of the sun's warmth. Their instruments have recorded the temperature of interstellar space, confirming what we long suspected, that the further you go from stars, the less heat you find, until all that remains is the faint murmur of the Big Bang's sigh. And still those little machines move on, powered by the last scraps of their energy sources, drifting like bottled messages in a frozen sea. They remind us of our own fragility, warm beings wrapped in cloth and curiosity, trying to make sense of a place that doesn't care whether we're warm or not. But also, they remind us of our persistence, that even in the face of such immense cold, we build tools, we ask questions, we launch our wonder into the dark. And you, lying here, eyes heavy, are part of that story. The warmth in your chest, the breath rising slowly through your nostrils, is the same. Warmth we've learned to protect in every satellite, every sensor, every ship that carries our dreams through the vacuum. We don't fight the cold, we learn from it, we map it, we marvel at it, and in doing so we leave little signatures of our presence in the universe. Not flames, but flickers, not noise, but echoes. And next, as we continue this weightless descent into frozen science, we'll explore what happens when warmth vanishes entirely, not just in space or sky, but inside matter itself, when atoms stop moving, when energy falters, and quantum mechanics begins to whisper secrets only the coldest conditions can reveal. Somewhere in a laboratory colder than any place you've ever imagined, there is a cluster of atoms, rubidium perhaps, floating gently in a chamber sealed from the outside world. Their movement so slow, so soft, that calling it motion at all feels like a kind of exaggeration. And as you lie still now, following the thread of our journey ever deeper into the layers of cold, imagine yourself shrinking, not metaphorically, but physically, until you are small enough to drift between those very atoms, floating in a kind of silence that is not just absence of sound, but absence of everything you've ever called alive. This is not just cold, this is near absolute zero. The place where heat, motion, chaos, all the things that make matter behave as it usually does, begin to collapse inward into something altogether different. And what's left at this bottom edge of temperature is something almost mystical, the Bose-Einstein condensate, a phase of matter so rare, so delicate, that it only exists for moments at a time before vanishing like frost melting on the tip of a warm tongue. And yet, in those brief flashes of existence, it tells us something profound, that even atoms, those restless, jittery dancers of the universe, can fall asleep. In this state, cooled to a soul, few billionths of a degree above absolute zero, individual atoms lose their separateness. They blur, they overlap, they merge into a single quantum entity, behaving not like a crowd, but like a single wave. You might expect silence at this scale, but what you find instead is harmony, a kind of unity that only appears when energy is stripped away, when motion is hushed. It's as though the universe reveals its truest self, not in its chaos, but in its stillness. And stillness, as you're beginning to feel, is not emptiness. It's structure. It's a kind of order that lies beneath all things. Picture a room full of people chattering, laughing, moving. Imagine now that room slowly quieting until no one moves, no one speaks, and yet everyone is still present. That's what a Bose-Einstein condensate is. Not the disappearance of atoms, but their agreement to behave as one. It's a kind of quantum consensus, and to get there, scientists must use tools so precise, so patient, that they feel more like lullabies than machines. They use laser cooling, firing beams of light at atoms not to heat them, but to slow them down, to trap them in patterns, to reduce their motion one photon at a time. It sounds contradictory, doesn't it? Using light to bring stillness? But in the world of quantum mechanics, contradiction is common. Down here, at the lowest energies, particles act like waves. Location becomes uncertain. Properties blend. The rules you thought were fixed begin to shimmer. It's not chaos, it's poetry written in uncertainty, and cold is the ink. You might wonder why this matters. Why should it interest you, here in your warm room, head resting on a pillow, drifting through layers of thought? Because it shows that the universe has different faces. That reality is not one rigid thing, but a spectrum. And at the coldest end of that spectrum, things become simpler, not more complex. The far, antic dance of heat calms into a quiet chorus. Individuality fades into unity, and that's something you've felt too in small ways, on nights when everything slows when your mind softens and you forget the borders between yourself and the world. That's the beauty of cold. It brings closeness. It draws particles, people, thoughts together. When atoms fall asleep, they stop bouncing off one another. They drift, they overlap, they become. And that act of becoming, of transformation through cold, isn't limited to laboratories. In a sense, you do the same thing when you sleep. Your brain quiets, your metabolism drops, your internal chatter fades. You stop reacting, you start restoring. Cold helps you get there. Even a small drop in body temperature cues your brain that it's time to release melatonin, to turn down the lights inside your mind. Your neurons fire more slowly. Your heart moves with less urgency. You don't vanish. You become simpler, softer, more unified. You become like those atoms, no longer separate, but flowing into a single wave of sleep. And perhaps, just perhaps, that's not so different from the universe at its coldest. Simplicity in place of movement, grace instead of force, a universe not expanding but resting. Even in nature we see echoes of this. Superfluid helium, when cooled near absolute zero, begins to flow without friction. It climbs walls. It slips through cracks no normal liquid can enter. It becomes a ghost of its warmer self, lighter, stranger, freer. And superconductors, those magical materials that lose all electrical resistance at low temperatures, become vessels of perfect motion. Electricity flows through them without losing energy, without heat, without noise. Cold doesn't just slow things, it refines them. It reveals potential hidden in the heat. So the next time you shiver, the next time your fingers search for gloves or your breath fogs the morning air, remember, cold isn't the enemy, it's the doorway, and beyond it lies beauty, precision, peace, the kind of peace you're starting to feel now, as your mind floats alongside particles that no longer care where they begin or end, atoms that sleep, waves that merge, thoughts that no longer need to hurry. And as we move forward, slower now, deeper still, we will wander into the cosmic consequences of this frozen clarity, into black holes, time dilation, and the paradoxes of space where cold collides with gravity and bends reality in ways we're only beginning to understand. You may not feel it right now as your body rests and your breath slows into the rhythm of dreams, but all around you, even here in the quiet darkness of your room, space is bending softly and silently under the weight of things too vast to see. And as we continue our descent into the coldest places in the universe, we find ourselves at the very edge of understanding, where cold meets gravity, and space-time itself curves like glass touched by frost. Imagine a black hole, not as a monster, not as a devourer, but as a still point, a place where motion stops and light forgets how to leave. It is not hot, despite the drama we often imagine. In fact, out beyond its swirling halo of heated matter, its event horizon, that invisible threshold beyond which no information escapes, is a region of unimaginable chill. Not because it steals warmth, but because it traps it. And here, cold becomes not just absence of heat, but a condition of space-time itself. Black holes are made when matter collapses inward so completely that it warps the very structure of the universe. Time slows there, not in a metaphorical way, but physically. If you stood at the edge of a black hole and looked outward, the universe would seem to race ahead without you. Minutes would stretch into years, hours into centuries. That's not theory, it's physics. Einstein's general relativity, which tells us that gravity and time are two sides of the same fabric. and the colder space becomes 2. The easier it is to notice this warping. Ever are. Sparks. Motions. Warm moments in the arms of a universe slowly cooling toward rest. But not yet. Not tonight. Because you are still here. Your thoughts are still moving. And this sleep you're slipping into is not an ending, but a pause, a temporary drift towards stillness, not its final form. You are safe, you are warm, and absolute zero, that perfect silence, is just a concept floating in the distance. Useful, beautiful, unreachable, like the horizon over an ocean you'll never need to cross. And as we near the close of our journey, we'll draw together everything we've seen, from the frozen stars to the sleeping atoms, from the brainwaves to the ancient ice, and gently ask, what does it mean to live in a universe that cools? What do we hold on to and what do we let go of as we drift between warmth and cold, between presence and rest? Let's follow that final thread softly now toward a peaceful end. There's a tender moment just before sleep fully claims you, when your thoughts begin to loosen, not disappear, just drift, no longer tethered tightly to form or urgency, but flowing like threads of light through cold water, soft and slow and strangely familiar. And in that moment, you understand something you've always known but never quite said aloud, that life is a balance between holding on and letting go. That warmth, your warmth, is not permanent, but neither is the cold. It is this in-between, this slow breath of motion and pause that makes the universe feel like home. We live in a cooling cosmos, yes, but we are not powerless within it. We are participants. We are the brief warmth that dances before the stillness, the soft defiance of entropy. We build fires. We share stories. We remember. We hold hands in the cold. And this beautiful act of holding isn't just emotional, it's scientific. At the atomic level, every interaction, every bond, every moment of heat is a kind of connection. Molecules cling together. Electrons share space. Even gravity, our oldest cosmic companion, is a way of holding on, of pulling close. But in the same breath, the universe asks us to let go. Stars let go of their light. Galaxies drift apart. Heat moves from warm to cold, always seeking balance. And we too must learn this rhythm, to love without possession, to remember without regret, to sleep without fear. Think of snow, how it falls without resistance, how it lands softly on the world, how it vanishes not with noise but with grace, or the way breath leaves your body at night, warmer than the air around it, then disappears into the room, forgotten and essential all at once. These are lessons in letting go, in being part of a process larger than yourself. And yet you hold on too. You hold on to your warmth, your memories, your dreams. You tuck yourself beneath blankets, build homes, build stories, build meaning. Even now, your body is busy keeping you warm, a quiet miracle of thermoregulation and evolutionary wisdom. Your blood moves, your muscles relax, your neurons fire gently in preparation for dreams. You are not passive. You are a participant in your own stillness. And that is what makes you human in a universe that does not ask for humanity. You bring purpose to the drift, and the universe in its own way responds. It allows warmth, it allows moments, it allows stars to burn long enough for planets to form, for oceans to churn, for life to emerge, for you to sit here, breathing slowly, thinking these thoughts. That's not coincidence, that's a gift of timing, a brief alignment in a long, cold story. So what do you do with this gift? You feel, you remember, you sleep, you dream. You let yourself soften into the calm that cold offers, not as a threat but as a mirror. Cold slows things down, and in that, where cold affects not the stars but the thoughts themselves, where your memories, emotions and dreams are shaped by the temperature of your cells and the silent chemistry of sleep. There's a kind of quiet that comes not from the world around you, but from the world within you. A hush that begins in your chest, travels through your breath, and settles behind your eyes like mist curling around a morning lake. And it's here, in the dim and gentle landscape of your own mind, that cold begins to whisper, not in numbers or physics, but in emotion, in memory, in thought. Your brain, though warm by biological necessity, is surprisingly sensitive to temperature. Just a small shift, a degree here, a fraction there, can ripple through your neurons like a breeze across a still pond, changing how you feel, how you think, how you remember. It's not dramatic, not explosive, but subtle, like dreams folding into one another while you sleep. You've likely felt it before, the calming chill of a cold cloth across your forehead when your thoughts are racing, the serenity of walking into cool air after a long day, the softness in your bones when you lie down under a fan, your body cooling just enough to release the static noise of worry. That's not coincidence, it's science. Your brain's rhythms, its deep electrical waves, its chemical choreography, all become quieter in the cold. The firing of neurons slows, the pace of thought eases. In extreme cases, hypothermia can cause confusion, drowsiness, even hallucinations. But well before that point, there's a gentler effect, clarity, calm, a kind of mental pause that lets you feel rather than think. This is partly why sleep happens more easily in a cool room. As your core temperature lowers, your body tells your brain that it's time to shift from activity to restoration. The release of melatonin increases, heart rate slows, blood vessels in your extremities dilate, letting heat slip from your skin like vapor. And in your brain, alpha waves rise, those quiet, looping rhythms associated with light sleep, deep meditation and peaceful awareness. You aren't switching off, you're tuning in, you're becoming more yourself by doing less. Cold helps that happen. It nudges the brain towards simplicity, and simplicity in the world of neural activity is not a downgrade. It's a return, a reconnection, a way of feeling the underlying tone of your own consciousness without the clutter of constant thought. And in this space, where the mind cools and the world slows, memories become softer too, not erased but less sharp, like photos in fading light. Neuroscience tells us that memory is an active process. Every time you recall something, you're reshaping it, editing it slightly, restamping it into your brain. But in colder conditions, this reshaping slows. Emotional intensity dims. That's why traumatic events, when recalled in safe, cool environments, often feel more manageable. The temperature doesn't erase the pain, but it takes the sting from the edges. Even animals understand this on some level. Hibernating creatures, bears, squirrels, bats, let their brain activity drop along with their body temperature, entering states where thought, movement, and even time itself become suspended. They don't dream in these states. They wait. They rest without restlessness. It's not death, it's protection. And while you don't hibernate, you mimic it in sleep. Your body drops a degree or two, your brain shifts into long, slow waves of delta activity, and you drift through dreams that make no logical sense but feel emotionally real. Cold helps that journey, keeps it steady, prevents the interruptions of heat, the flaring of cortisol, the tossing and turning of a mind too warm to let go. Even in your waking hours, a splash of cold water, a wee bulk in the wind, a breeze through an open window, all of it touches your mind, not just your skin. The nerves in your face and neck connect to your vagus nerve, a long and winding communicator between brain and body. When stimulated by cold, this nerve helps reduce stress, slow breathing, and create a sensation of grounded calm. That's why cold plunges have become a therapeutic trend. That's why athletes soak in ice baths, not just to soothe muscles, but to center the mind. Cold doesn't just shrink blood vessels, it expands awareness. And as your thoughts wander now, gently, you might feel a sense of connection, not just to the science of this process, but to the emotional truth of it. That cold, despite its reputation, is not an enemy to be escaped. It's a companion, a guide, a teacher that shows you how to slow down, how to feel more with less. And your brain, fragile and vast, is listening. Every synapse, every cell is a tiny spark surrounded by cold possibility. And at the deepest level, quantum biology suggests that even your neurons may use the strange behaviors of particles at near zero temperatures to transmit information. Tunneling, coherence, phenomena that feel more at home in physics than physiology. But your mind, it seems, is not just a thinker, it is a field, and temperature alters that field like weather shapes a landscape. And so, as you lie here, as your thoughts soften into feelings and your feelings dissolve into breath, know that your brain is not alone. It is part of this universe responding to its temperature shaped by its cold. Just as stars pulse with heat, you pulse with thought. Just as the void hums with cosmic microwave background radiation, your mind hums with the echoes of your day. And cold lets those echoes quiet, lets them fade without disappearing, lets them become something gentler, something that carries you softly into rest. And as we continue, let us follow that hush beyond the body and the brain, into the surreal intersection of cold and time itself, where centuries pass in stillness, and where cryonics, suspended animation, and theoretical pauses in human life begin to resemble not science fiction, but the slow science of becoming timeless. You've felt time stretch before, perhaps in a quiet waiting room, or during the last seconds of a meaningful conversation, or in the way night seems to linger when you're too tired to move but not tired enough to sleep. But what if time didn't just stretch? What if it stopped? Not for everyone, not for the whole world, but just for one person, one body, suspended delicately in the soft clasp of ice, caught between the beat of one heart and the potential of another. That is the quiet dream of cryonics, not a fantasy of immortality or science fiction's dramatic awakenings, but a slow and careful hope rooted in the nature of cold itself. The idea is simple in its ambition. If heat is motion and life is built upon motion, then perhaps by stopping that motion, by cooling the body to temperatures so low that metabolism ceases entirely, we can pause the story of a human being, not end it, just press pause. It begins at the edge of death, where the breath fades and the heartbeat stills, and the process must begin quickly. Cryonics technicians work to preserve the body, not with ice, but with vitrification, a form of cooling that turns water within the cells, not into frost, but into glass. Ice crystals can tear the fragile walls of your cells, but glass preserves their shapes perfectly, freezing not just tissue, but identity in a motionless, sleeping form. The human body in this state is stored at 196 degrees Celsius in dewars of liquid nitrogen, silent chambers of silver and steel that hold time itself in stillness. And there, in that cold, you do not age, you do not heal, you simply wait. You become a question instead of an answer, not alive, not dead, not dreaming, just paused. The science is imperfect, of course. We cannot yet reverse this process, cannot yet bring back a human from vitrified suspension. But we understand enough to imagine it. Frogs in the Arctic freeze solid in winter and return to. But we understand enough to imagine it. Frogs in the Arctic freeze solid in winter and return to life in spring. Certain fish and insects survive beneath layers of ice, their cells protected by antifreeze proteins, their lives flickering back on when the warmth returns. In laboratories, human embryos are frozen and stored, thawed and grown into full lives. The principle exists. The process is a work in progress. But cold, we've discovered, is patient. And time, when asked to stop gently enough, sometimes agrees. This idea that cold can hold time is not just biological, it's physical. In thermodynamics, entropy is the measure of disorder, the tendency of systems to move from order to chaos. It's the arrow of time. But cold slows entropy. It delays the unravelling. In a sense, the colder something is, the slower it falls apart. That's why we refrigerate food, why we freeze samples in labs, why museums keep ancient scrolls in cool, dry vaults. Cold is a caretaker of time. It protects, it preserves, it holds the past so the future might still touch it. And your body too reacts to this principle. When hypothermia sets in, systems slow. The heart beats fewer times. The brain uses less oxygen. In extreme cases, drowning victims who fall into icy water can survive far longer than those in warm water because the cold protects them. It buys time. It lowers the metabolic fire just enough to keep the embers alive. Emergency medicine has begun to harness this, using induced hypothermia to protect patients during surgery, to slow brain damage after cardiac arrest, to give doctors more time to work. It's not magic, it's science, quiet science, the kind that whispers instead of shouts. And beneath that science lies a question both philosophical and personal. What is life, really, if it can be paused? If memory can be frozen, if cells can sleep, if a person's story can be interrupted, not ended. In a way, we all participate in this idea. Every night when you sleep, you give up the reins of your life. You enter a kind of stillness, and your body cools slightly. Your brain slips into patterns that make little sense to the waking world. You forget time, you dream, and in the morning, you return. Cryonics is a version of that idea written in deeper ink, a longer night, a slower breath, a dream that waits not for dawn, but for the right tools, the right warmth, the right hands to lift it gently back into motion. And so, as you lie here now, wrapped not in nitrogen but in blankets and breath, you can feel a kind of kinship with those who wait in silver chambers, not as frozen ghosts, but as paused potential. Like seeds waiting for rain, like letters waiting to be read. Not every story ends. Some stories wait, some stories stretch across centuries. And in a universe where time moves forward but temperature slows it down, perhaps the coldest places are not ends at all, but beginnings written at a slower speed. Already your body knows this. Your cells remember the cold. Your brain has felt it in every winter, every chilled breeze, every time you stepped into a cold room and found your thoughts becoming clearer, your senses more focused, your awareness deepening. Cold does not erase you. It holds you. And as we move into the final chapters of our journey, deeper into the slow spiral of cosmic temperature and personal stillness, we'll explore what it means to truly belong to this universe, to live within its cooling, stretching story, and to find your place not just among the stars, but among the temperatures that shaped them. Out here in the sweeping arms of time and temperature, you begin to understand something quietly profound, not through logic or formula, but through the stillness that seeps into your breath, the calm that comes from imagining yourself not apart from the universe, but as part of its great, gentle exhale. The universe is cooling, not dramatically, not like ice snapping over lakes or winds howling down from Arctic shelves, but slowly, patiently, as if the entire cosmos is settling into a more restful state. Since the Big Bang, that original storm of impossible heat and density, everything has been drifting, expanding, relaxing. Galaxies unravel like threads in a tapestry. Stars burn through their fuel and fade. The cosmic microwave background, faint and constant, is the leftover heat of a beginning that's now so far behind us it feels like myth. And yet it's not myth, it's physics. And the average temperature of the universe has been falling ever since. You live in a world that once shimmered with unimaginable fire, but now glows only faintly, like embers buried beneath ash. This idea may sound sad, but it's not. There is peace in it. The kind of peace that comes from understanding where you belong in a story that's still being told. Because here's the quiet truth. You are a warm creature in a cold universe. A flicker of energy in a place that prefers stillness. And that flicker matters. Against the backdrop of infinite expansion and cooling, the heat in your chest, the little furnace of your body, your thoughts, your memories, is something rare, temporary, yes, but meaningful. And what's more, you are made from the ashes of stars that burned far hotter than the sun. Every atom in your body was forged in stellar collapse, in the pressurized hearts of suns that flared, exploded, and scattered their contents across the universe like seeds in wind. Iron in your blood, calcium in your bones, carbon in your breath, all born from heat, all now resting in you. But the story doesn't end there, because even the atoms themselves, the electrons and protons and neutrons that form everything you are, vibrate less as temperature drops. Eventually, in the distant future, far beyond any calendar we could ever mark, the universe may reach a point of maximum entropy, a state where energy is so evenly spread out that no motion, no heat, no contrast remains. Physicists call this heat death, but it's really a kind of cosmic sleep, not destruction, not silence, just rest. And as strange as it seems, your body knows how to prepare for that. Every night, as you fall asleep, you lower your temperature, your metabolism slows, your thoughts drift from the urgent to the abstract. You enter a smaller version of the universe's cooling process, a nightly echo of a billion-year rhythm, and in that way, you are not merely observing the universe, you are mirroring it, living it, feeling it inside your own bones. When you reach for a blanket, when you curl into a tighter shape, when you surrender to drowsiness, you're acknowledging that belonging. You are not fighting the cold, you are dancing with it, sharing your warmth gently for just a little while longer. And that's all the universe asks. Not permanence, not perfection, just participation. To be a moment of heat in a field of cold. A note in a song written across light years. And your moments are filled with motion, your heartbeat, your breath, your quiet thoughts that drift like leaves across the surface of your mind. Even now, as you settle deeper into this resting state, there is motion in you, but it's slower now, softer, a kind of thermal whisper, still warm against the slow drift of universal time. And in that warmth, there is beauty, because it's not the cold that makes meaning, it's the contrast. Stars shine because space is dark, hearts beat because silence surrounds them, life matters because death is real. Warmth matters because it stands out, it glows, and you, whether asleep or awake, are aglow in this universe. A traveller made of ancient stardust, breathing borrowed heat, dreaming borrowed dreams. And one day, long after suns have cooled and galaxies have dispersed, the particles that once formed you will still exist, floating through space, no longer warm, no longer aware, but still part of the great story. You won't be erased. You'll be distributed, folded back into the fabric, not lost. Just transformed. And perhaps, if consciousness is more than chemistry, if some whisper of thought lingers in the spaces between neurons, in the quiet of atoms, then some part of you may feel that cold not as an ending, but as a return, a homecoming, a soft light fading into a softer dark. Until then, you are here, and that is enough. You are the brief flare of energy in a universe of cold possibilities, a warmth that knows how to reflect, how to hold, how to let go. So breathe deeply. Let your body remember the rhythm of the stars. Let your mind stretch out into the spaces between seconds. You are not alone. You are never alone. You are the universe, cooling gently, thinking softly, sleeping peacefully. And as we move into the final chapters of this journey, we'll drift gently downward into the ground beneath you, into the Earth's own icy vaults, where ancient cold holds the deep time of our planet, and where frozen forests and mammoth bones whisper stories of life slowed, but not lost. Beneath your feet, deeper than roots can reach and quieter than any sound you've ever heard, lie the frozen pages of Earth's forgotten diary, sheets of ancient ice, locked in place for thousands, even millions of years, each layer holding a whisper from a world long gone. And now, as you rest here, your breath gentle, your limbs wrapped in stillness, let your thoughts fall down, ward past the soil and stone, into those cold archives, glaciers, permafrost, polar caps, where time is not marked by clocks, but by snow that never melted, by air that hasn't moved in 100 centuries. These places are not just cold, they are memory, preserved. In Antarctica, scientists drill deep into ice cores, extracting slender cylinders of time. Each layer in these frozen columns tells a story, a season, a storm, a fire on the wind. Microscopic bubbles trapped inside the ice still hold the breath of creatures who lived before history began. Carbon dioxide, methane, sulfur, ancient air, inhaled once by mammoths or forests or volcanic skies. As you exhale now, warm breath slipping invisibly into your room, remember that even your air was once elsewhere, part of a cycle, a memory, an echo. The Earth has been breathing for billions of years, and the coldest parts of it have been listening. In Greenland's ice sheet, layers go back 130,000 years. Far beneath the surface, the temperature remains steady, silent, sacred. These layers are so delicate, so precise, that researchers can read them like a novel, counting snowfall year by year, discovering when volcanoes erupted on the other side of the world, tracking how the planet warmed and cooled long before we ever walked on it. And in Siberia, permafrost locks away even more. Roots, spores, carcasses of long-dead animals sleeping beneath the tundra in frozen stillness. Scientists have found viruses still intact in this icy tomb, dormant but not destroyed, like notes left unread in a bottle drifting across centuries. In 2012, a 30,000-year-old seed was found deep in the Siberian permafrost. When thawed and planted, it bloomed. A white flower, delicate and soft, born from cold and darkness, its DNA untouched by time. That flower was not a miracle. It was a reminder that life waits, that cold does not erase. It stores, it preserves what heat might burn away. It cradles the fragile, the quiet, the important. And beneath the Antarctic ice lies something else, a lake called Lake Vostok, sealed away beneath 4 kilometers of frozen silence. It has been untouched by sunlight for over 15 million years, and yet we believe it holds life. Microbes adapted to the darkness, sustained by minerals and geothermal heat. Not thriving, perhaps, but surviving. And that survival in cold so deep it breaks steel tells us something incredible, that life is not deterred by cold. It adapts, it slows, it dreams. You too are part of this legacy. Your own body carries adaptations to cold. Goosebumps, fat storage, blood vessel regulation, all ancient tools gifted by ancestors who huddled in caves, wrapped in furs, listening to the wind sing over the ice. Even today, cold has a power over your instincts. It makes you conserve. It sharpens your senses. It brings you inward. And that instinct to draw close, to hold warmth near, is not just comfort. It's evolution, wrapped in emotion. Your skin is more than boundary. It's a storyteller. Every time cold brushes your neck or fingertips, it's telling you something old and true. This is the world. This is what shaped you. And far below, in the deepest ice, those stories continue. Scientists have even used ice to look not just backward, but forward. By analysing ancient temperatures, trapped gases and stable isotopes, they model the planet's future. They see the warming, the melt, the shift, but they also see the resilience. How life returned after ice ages, how species migrated, how forests crept back up the mountains. The earth is not static, it breathes slowly, and cold, far from being its enemy, is its editor, cutting, preserving, reminding. And as you lie here, your own temperature gently lowered by sleep's approach, you are sharing in that rhythm. You are a creature of climate. Your own emotions even are tied to temperature. On colder days, your brain becomes slightly more focused, more reflective. Your metabolism shifts, your cravings change, and in the hush of winter nights, you think longer thoughts, deeper ones. The world feels larger. Time feels slower. That's no illusion. It's biology in motion. Cold lengthens perception, draws attention inward, allows your mind to wander without rushing. Like a glacier carving a valley, it gives shape by moving slowly. And perhaps that's the true gift of Earth's ice. Not just the preservation of data, but the permission to slow down. To remember that motion is not always the answer. That stillness too is powerful. That cold can clarify what heat distorts. That silence can speak. So let yourself sink a little deeper now into the quiet that spans continents, into the frost that holds ancient leaves, into the idea that your life too is part of this planetary dream, a warm thought wrapped in a cold memory, resting for a moment in the arms of time. And as we approach the final layers of this journey, we'll turn our gaze not downward but inward into the very definition of cold, into the strange, slippery truth of absolute zero, where temperature ends and possibility begins, where time freezes and the universe holds its breath. Somewhere far below the freezing point of every familiar thing, colder than winter wind, colder than dry ice, colder than the frost on a window pane forgotten at dawn, there lies a temperature so quiet, so still, that it begins to feel less like cold and more like the absence of movement itself. This is absolute zero, not a suggestion, not a metaphor, but a real number. 0 Kelvin, or 273.15 degrees Celsius, the bottom, the end, the place where all atomic motion, in theory, halts. And as you settle deeper into your rest, breathing slow, and now body warm and still beneath your covers, you can almost imagine it, the vast hush of a universe with no energy left to spend. No vibration, no twitch, just stillness so pure it doesn't even echo. In a sense, absolute zero is the coldest idea imaginable, not just because of its temperature, but because of what it means. Motion is life, and this is the end of motion. Energy is change, and this is the absence of change. It's a place where nothing stirs, not because it's forbidden, but because it has simply run out of reasons to move. But here's where the science becomes beautiful. Despite our best efforts, our finest lasers, our vacuum chambers, our magnetic traps, we have never reached absolute zero. We've come close, unimaginably close, to within billionths of a degree, but never all the way. And this impossibility is not due to technical failure, but to the laws of the universe itself. The third law of thermodynamics whispers that as you approach absolute zero, the energy required to cool an object further increases exponentially. In other words, the colder you get, the harder it becomes to get colder. Nature puts up a wall, not abrupt, not cruel, but unpassable. A soft no at the end of all cooling. And that impossibility, that unreachable flaw, tells us something profound. The universe always keeps a little motion, a little possibility, alive. Even at the edge of stillness, some quantum flicker remains, a zero-point energy, a wiggle beneath the silence, because in the quantum world, nothing is ever fully still. Uncertainty lives everywhere. Particles flicker into and out of existence, even in a vacuum. So even in a perfect cold, there's something, some whisper, some echo. Absolute zero then becomes not a temperature but a concept, a boundary we approach but never cross, a kind of quiet horizon, and in that boundary lies meaning. Because your atoms, too, obey this rule. Even as you sleep and your temperature drops and your body goes still, you are never truly frozen. There is always a flutter in your molecules, a hum in your cells, a warmth in your breath. You are the defiance of absolute zero, and yet you are shaped by it. Your entire understanding of temperature, of heat, of time even, bends toward this unreachable point. Scientists use it as a reference, zero. Kelvin as the anchor against which all warmth is measured. In cryogenics, in astronomy, in particle physics, absolute zero is the backdrop of every question. What would happen if we could stop everything? What would the universe look like, feel like, become? And yet the closer we get, the stranger the world behaves. At nano-Kelvin temperatures, atoms begin to blur together. Matter forms Bose-Einstein condensates, where thousands of atoms occupy the same quantum state. They lose individuality. They become waves instead of particles. Matter forgets itself and becomes something new, something dreamlike. And in those dreams, we glimpse what reality looks like, without noise, without chaos, without heat. Perhaps that's what you're feeling now, the slow slide towards simplicity. Your thoughts no longer scattered, but pooled, your breath rhythmic, your awareness stretched across the edges of sleep. You're not unconscious, you're condensed, becoming part of something wider, deeper, stiller. Something cold, but not lifeless. Something still, but not empty. And as you hover near this idea, the threshold of all motion, you begin to sense the strange optimism hidden in it. Absolute zero is unreachable, but because it is, everything else moves. Because we can't reach stillness, we must dance. Because we can't pause time, we live. And that's not a flaw, that's the frame. Even the universe, as it cools across billions of years, will never truly freeze. Background radiation will thin, stars will fade, matter will decay, but some flicker will remain, a gentle drift of particles, a final spark of potential, a footstep in the snow of space, and perhaps that's all we ever are. Sparks, motions, warm moments in the arms of a universe slowly cooling toward rest, but not yet, Not tonight, because you are still here. Your thoughts are still moving, and this sleep you're slipping into is not an ending, but a pause, a temporary drift towards stillness, not its final form. You are safe. You are warm, and absolute zero, that perfect silence, is just a concept floating in the distance, useful, beautiful, unreachable, like the horizon over an ocean you'll never need to cross. And as we near the close of our journey, we'll draw together everything we've seen, from the frozen stars to the sleeping atoms, from the brain waves to the ancient ice, and gently ask, what does it mean to live in a universe that cools? What do we hold on to, and what do we let go of as we drift between warmth and cold, between presence and rest? Let's follow that final thread, softly now, toward a peaceful end. There's a tender moment, just before sleep fully claims you, when your thoughts begin to loosen, not disappear, just drift, no longer tethered tightly to form or urgency, but flowing like threads of light through cold water, soft and slow and strangely familiar. And in that moment, you understand something you've always known, but never quite said aloud, that life is a balance between holding on and letting go. That warmth, your warmth, is not permanent, but neither is the cold. It is this in-between, this slow breath of motion and pause that makes the universe feel like home. We live in a cooling cosmos, yes, but we are not powerless within it. We are participants. We are the brief warmth that dances before the stillness, the soft defiance of entropy. We build fires, we share stories, we remember. We hold hands in the cold, and this beautiful act of holding isn't just emotional, it's scientific. At the atomic level, every interaction, every bond, every moment of heat is a kind of connection. Molecules cling together, electrons share space. Even gravity, our oldest cosmic companion, is a way of holding on, of pulling close. But in the same breath, the universe asks us to let go. Stars let go of their light. Galaxies drift apart. Heat moves from warm to cold, always seeking balance. And we too must learn this rhythm, to love without possession, to remember without regret, to sleep without fear. Think of snow, how it falls without resistance, how it lands softly on the world, how it vanishes not with noise but with grace. Or the way breath leaves your body at night, warmer than the air around it, then disappears into the room, forgotten and essential all at once. These are lessons in letting go, in being part of a process larger than yourself, and yet you hold on too. You hold on to your warmth, your memories, your dreams. You tuck yourself beneath blankets, build homes, build stories, build meaning. Even now, your body is busy keeping you warm, a quiet miracle of thermoregulation and evolutionary wisdom. Your blood moves, your muscles relax, your neurons fire gently in preparation for dreams. You are not passive. You are a participant in your own stillness. And that is what makes you human in a universe that does not ask for humanity. You bring purpose to the drift, and the universe, in its own way, responds. It allows warmth, it allows moments, it allows stars to burn long enough for planets to form, for oceans to churn, for life to emerge. For you to sit here, breathing slowly, thinking these thoughts. That's not coincidence. That's a gift of timing, a brief alignment in a long, cold story. So what do you do with this gift? You feel, you remember, you sleep, you dream. You let yourself soften into the calm that cold offers, not as a threat, but as a mirror. Cold slows things down, and in that slowing, we find space to think differently, to feel more deeply, to ask not how long we have, but how fully we can be here, in this moment. And the answer is always more fully than you realize. Because right now, even as your eyes close and your thoughts dissolve, you are still here, still participating, still holding on to something, even as you begin to let go. Perhaps it's a memory, a face, a feeling, a place you once knew. Perhaps it's hope, or peace, or the quiet satisfaction of understanding something vast and invisible, like the way ice forms on glass, or how stars collapse, or why dreams feel more real when the world is silent. Whatever it is, let it stay for a moment. Let it warm you. Then, when you're ready, let it drift. Let it become part of the cooling breath of the universe, part of the gentle rhythm you now belong to. Because this journey through the coldest places in existence has never really been about science alone. It has been about feeling small and vast at once, about understanding your place among the galaxies, the atoms, the waves of heat and stillness. And what you've found again and again is that you are never truly separate from it. You are not watching the universe from the outside. You are woven into its fabric. You are the warmth it briefly holds, the question it asks itself, the hand it gently reaches toward. And as your breath slows further and the line between wakefulness and rest begins to fade, know that there is nothing more you need to do. You have held on long enough for tonight. You have listened. You have wondered. You have felt the cold, not as an end, but as a teacher. And now, softly, gently, it's time to let go. Time to let your body drift into the deeper layers of sleep, where thoughts are not so sharp, where time moves differently, where you are safe and quiet and completely yourself. We'll return once more in one phase. Chimnol chapter. To gently seal the story, to bring warmth back into the room, not with fire but with meaning. With the soft understanding that in a cold universe, the warmth we carry is not just survival, it's the point. Hey guys, before this journey fully fades into the silence of sleep, let me gently bring you home, not with a grand conclusion, but with a final warmth, like the glow of embers after a long, dark night. You've travelled far tonight, not across countries or planets, but through layers of temperature and time, through the chilled breath of stars, the frozen memory of ancient Earth, and into the deepest corners of your own quiet mind. And now, as we close this journey together here at Boring Science for Sleep, I want you to think of one final idea, that the warmth you feel is not just in your skin, but in your story. You are not just a body tucked beneath blankets. You are a keeper of heat, a flickering, beautiful defiance of the cold that waits everywhere else. You are a temporary miracle in a place that tends towards stillness, and that is not frightening, it's exquisite. You are not here by accident. You are not a meaningless collection of atoms drifting through a forgetful cosmos. You are a brief light, one that holds warmth, not just physically, but emotionally, scientifically, and philosophically. Every smile you've shared, every laugh, every tear, every gesture of care or connection or memory, it radiates out far beyond your skin, and even after you've forgotten those moments, they still exist, like heat escaping a star long after it has gone dim, still travelling, still touching, still warming something unseen. This is the legacy of heat in a cold universe. It doesn't have to last forever to matter. It just has to have been real. And you, tonight, right now, are more real than you realise. Your heartbeat, slow and steady. Your breath, rhythmic. Your thoughts, softened into the lull of near dream. All of this is part of the great dance between warmth and cold. You are not above nature. You are not separate from it. You are nature. You are the cosmos, experiencing itself for a little while, in the form of a person lying peacefully at the end of a long day, letting go without resistance. That's what this entire journey has been about. The coldest places in the universe were never just temperatures on a scale. They were reflections, reminders. The void between galaxies reminded you that space is wide, and that silence can be beautiful. The brains that slow in cold taught you that rest is a gift, not a weakness. The ancient ice beneath your feet whispered that memory can survive in stillness. And absolute zero, so unreachable, so abstract, taught you that we never truly stop moving, even when we're at rest. That life never truly disappears. It changes, it cools, it waits, and it continues. Even when you're gone, when your warmth has faded and your breath no longer leaves clouds on cold mornings, the warmth you've shared will remain, in people, in places, in moments. You won't be measured by your temperature, but by what you warmed. That is the soft promise of science and the quiet hope of sleep, that we are more than numbers, more than mechanisms. We are stories made of stardust, still learning to rest. So let yourself drift now. You don't need to think anymore. You don't need to hold on to any facts, any names, any details. Let them melt away like snowflakes on your palm. All that matters is this moment, this warmth, this breath, this quiet awareness that you are safe and small and part of something endlessly large and endlessly kind. In a few hours, the sun will rise somewhere, not for you to rush, not for you to chase, just for you to gently notice. The earth will rotate, as it always has, slowly revealing warmth to the parts of it that had cooled, and maybe you'll wake then, or maybe later, or maybe you'll wake just enough to shift under your blanket and smile without remembering Wu. Hi, and that's okay. That's enough. You've earned this rest. You've walked through galaxies of frost and silence and returned carrying only calm. And if you dream tonight, perhaps you'll drift among stars, or glide beneath frozen oceans, or float in still chambers of ice where time itself yawns softly and blinks. Or perhaps your dreams will be simple, familiar faces, warm lights, quiet footsteps through snow. Whatever they are, let them come gently. Let them wrap around you like another blanket. You are no longer chasing questions. You are embodying answers. Your temperature is perfect. Your mind is slowing. Your story continues, even in stillness, even in sleep. So take one more breath. Let it go. Let everything go. And know deeply, silently, that your warmth will last longer than you think. That cold is not the end, it is the beginning of understanding, and you, dear traveller of frozen places, are finally home. Good night.